Good morning, everybody. This is going to be Codeforces round 799. It's a Div4 contest. I'll be doing it in front of you in Java. I'll be using Eclipse as my IDE of choice. And if you want to use this submission template I have, you can go to codeforces.com/profile/second-thread, and then you can go to my submissions, and you can see all of the submissions that I've done. You can click on any one of them, and these will have my source code. So you can look at this, copy this, and then remove the stuff in the main method. Alright, the contest just started. Let's jump into it and solve as many problems as we can. Marathon. We have 4 distinct integers, A, B, C, and D. So output the number of things bigger than this. So 2. Yep, alright, we can do that. Here we go. Multi-test case. Array 4. I'm going to submit this, and we'll run it here. Good. All right. So we got the first sample. That means it's right. Awesome. All distinct. Problem B. Show has an array of n integers. Each operation consists of choosing 2 distinct integers, I and j, removing ai and aj from the array. So you can remove any 2 things. The resulting array. Oh, so only distinct and is as long as possible. So how many distinct ones are there? And then you have to subtract an even number. Okay. So we'll say int n equals this, and then int array equals fs dot. We're going to use a hash set to count duplicates, and then we're going to add all of the things in the array to the hash set. So now we'll have everything in this hash set will be how many things there are, and then int remove equals n minus unique dot size. And what's the answer? The length of the final array. Okay. So if removed mod 2 equals 0, out.println unique dot size, else out.println unique dot size times 1. 2124 looks good. So yeah, the trick there we'll just use a hash set to count how many things are unique. Where is the bishop? Alright, so we need to print the location of the bishop. 4-3, looks good. So it's the row and column that has 1. Okay. Oh, it's not on the edge of the board. So yeah, it's just the one where you've got the 5 spaces around it. Okay. We can do that. So it's 8 by something. Alright, and then 4 is 0, x is less than 8, x plus, y equals 0, y is less than 8, y plus, forward at x, y equals, what's it, hashtag, and forward at x plus 1, y plus 1 equals hashtag, and forward x plus 1, y minus 1 We're going to add these two more conditions. These would be minuses. Where's the minus sign on my keyboard? Okay. Alright, cool. Then this out. Y plus 1 plus a space plus x plus 1. Because I do things 0 indexed, but they want it to be 1 indexed. Yeah, so we should go from 1 to 7. Because we know it's not on the edge of the board. What's wrong? Null pointer exception. What's the name? 3, 4, 2, 2. I have it backwards. Alright. Looks good. Submit. C. Awesome. Okay. Try and read problem D here. This is very likely right. The clock. Victor has a 24-hour clock that shows the time in the format hour, hour, minute, minute. He looks at the clock every X minute and it's currently showing time S. Okay. How many different palindromes will Victor see in total after looking at the clock after X minutes? This is annoying. Okay. Every 360 minutes, you'll see 1. Oh, man. Okay. How many different palindromes? It's just a lot to code. I'll come back. I mean, it's not hard, it's just a lot. Binary def. Slavic has an array n consisting of only zeros and ones, and one operation here moves to the first to last element. What's the minimum number of operations to perform such that the total sum is equal to s after performing all the operations? Oh, okay. So you need the sum equal to 3. Oh, the sum equal to 1, okay. Sum equal to 1 operation, 3. It's impossible to print -1, okay. Alright, so we can do this. So we have int n equals this, k equals this, int sum equals 0, yeah, so maybe arrays dot fill -1, and then we'll say for int for int I equals 0, less than n plus, if a at I equals 1, then sum plus plus, and we'll say index of its sum equals I after we increment it. Alright, so now if k is greater than sum, then out that print line, -1, continue. Otherwise, we need to subtract sum minus k. So then for int L equals 0, L is less than equal to sub, L plus plus, and L cost will be the index of at L, and R cost will be n minus this plus 1, I guess. Unless L is 0, so if L equals 0, then -1. Otherwise this, okay. So this will be L equals sub. If it is equal to sub, then we return 0. Otherwise we return n minus index of, how many will be from the right? Sub minus L plus 1. We already have the plus 1 because 1 base, and then okay, we need ants. Index of a sub plus 1. And ants equals math.min of ants and L cost plus R cost. Zero, 1, 4, 2. This is not 4. Okay, so the third case I get wrong. This one. So we need a sum to be 3, so the answer is 1, 2, 3. So when L is 0, it's 0 and 6. Yeah, 1, 6 is not right. Should be 4. This is going to be so kth will be sub minus L. This is n minus kth. Minus 1. N minus kth. Okay, so this is. I think this is all right. Why 10? That's definitely not right. This shouldn't be 10. It should be 4. Okay, what is kth? So kth is sub, would be 2. 2 minus L, so 2 minus 0, so it's 2. K is 2. This is sum minus kth. 2, 3, 4, 5. So not 5, would be 4. So kth is 2. Sum minus kth. Plus 1. So this one's 4, and then 1, and then 0. Okay. That may have taken as long as just implementing the right problem. Or implementing the next problem. Anyway. Very messy. Okay. Not too proud of that one. This is actually E. Oh, this is E. Okay, good. We'll probably go on to D now. Yeah, okay. D it is. You know, they say that comparison is the thief of joy. I heard this from John Christ. But that's only true when you're comparing yourself to people who are better than you. When comparing yourself to the scrubs in Div4, comparison is the source of happiness. Okay, clock. So yeah, we have this 24-hour clock. We add palindromes to it, or we look at it X minutes until what? You look at it every X minutes forever? Okay. Fine. So I guess we'll have static void solve int h and m. Alright, and then what is this? The hours and the minutes. Okay, so we have this, and that's it. We have to read an input. Okay, so string parts equals fs.next dot split at, okay, I guess, yeah, and then we need int k equals this, and h equals integer dot parse int parts dot substring from 0, or substring from 0 to 2. And then we want minutes equals integer dot parse int parts dot substring starting at index 3. Okay, and then solve HMK. Alright, so we need system.out.println ants. So this will be to the array. It'll be hours by minutes. So how many hours are there? There are 24 hours in a day. How many minutes are there? There are 60 minutes in an hour. Alright, so while not hit at HM, do some stuff and then increment by k. Alright, so then increment by k. So we'll say m plus equals k, while m is greater than or equal to 60. M minus equals 60. H plus equals, or H plus plus, H mod equals 24. So as times go hit 0, 0, they never hit 24, so we should be good there. What is midnight? Yeah, okay, so it's, makes sense. Alright, so now, if is pal, hm, then ants plus plus. So how do we check if this is a pal? So if h is less than 10, our return is pal s. So then s plus equals 0. And then we'll say s plus equals h, s plus equals a colon. If m is less than 10, s plus equals 0, s plus equals n. Alright, so this will just be return s at 0 equals s at return S0 equals SS at SS.length minus 1, and SS at 1 equals SS at SS.length minus 2. This is how you check if something is a palindrome in general, by the way. If the first character is the same as the last, and the second character is the same as the second last, that means everything is a palindrome. It's always palindrome. Guaranteed. Okay, and then we need hit at HM equals true. Yeah, you can check if a string of length n is a palindrome in order one time. Pretty cool. Okay, let's look at this three-sum problem. We have an array. I'm kidding, by the way. It's a sarcasm. In case you're very new to it, that doesn't work, obviously. You can have a 6-letter character. You need to check the third and fourth characters to make sure they match. Given an array A and a positive integer n. Nope, given an array n. Try number 3. Given an array A of positive integers n, determine if there exists 3 distinct integers, I, j, and k, such that their sum ends in the digit 3. So all we care about is the values mod 10. And if there are duplicates, we only need 3 of each. So although n can be up to 2 times 10 to the 5th, we only really care about 30 elements. And then we can do an n cubed from that. Cool problem, though. So we can say array list integer A, array list, and then we'll take int n with this, say int array A, if I start read array size n, or the hash map, I guess we'll have just int array cs, new int array 10. For each int in this array that we read, we'll say if cs at I is less than or equal to 3, then L dot add I. So this says if this is less than our third one, we'll take it, and then we'll do a triple for loop. So for int I equals 0 is less than L dot length, or L dot size. Int j equals I plus 1, j is less than L dot size, j plus plus. Int k equals j plus 1, k is less than L dot size, k plus plus. And then if L dot get I plus, well, okay, so int have equals L dot get I plus L dot get j plus L dot get k. And then we have Boolean works. If it does work, yes, otherwise, no. And then works or equals have mod 10 equals 10. How do you type? Equals 3. Looks good. Got it? 2 to the sort. Given an array A of length n and an integer k, find the number of indices I up to n minus k such that the subarray from I to the next k elements of length k plus 1, not with length k, has the following property. If you multiply the first element by 2 to the 0, and the next element by 2 to the 1, and so on, the subarray is sorted in strictly increasing order. It's probably going to be a lot of things. Yeah, probably a lot. So how big is n? N and k are big, but we only have to check like the first 20 things, because after that it will be sorted. Oh, unless we have zeros. But we don't have any zeros. Oh, JK, it's not. You just it's just so you just look at the pairwise things. So it's like the next one is over twice the size. Yeah. So you just look at when is there, so this one's all of them except this. So you have certain breaks. And the question is like, how many things are there that fit within the breaks and also the right length? Okay, yeah. So we can do this pretty easily. What? G? Here we go. Nope. Is it H? This is G. What have I been doing? Okay, well, I don't know if I messed this up. We'll just call this one temp2. Yeah, so length n equals this, and then k equals this. And we'll say int array a, read array size n. And then we need to solve this, right? So line ants equals 0, line ants. Importantly, I'm using a long here because there can be more than 10 to the 9th answers. There can be more than a billion arrays. Oh wait, it has to be length k? It does have to be length k. Okay, so no, they're only empty, so this can be an int. Never mind, we're fine. Alright, so then we want all of the breaks. Yeah. So we'll do a tree set. Then we'll go through all of the indices from 0 to n. And then we'll say if a at I is less than a at I plus 1 times 2. Is it sorted in ascending or in strictly ascending? So less than or equal to. Then breaks.add I. Okay? And now we need to say for I equals 0 less than n x plus. If next equals breaks.ceiling of n, row of I. This should be an integer because it can be null. And then if next equals null, we should just, we can just make it an int. And then we can say breaks.add and minus 1. So if next minus I, this is plus 1. That's how many things are in it. K plus 1 things? Yeah. So if this is greater than k, right? Because there are k plus 1 things. Like k plus 1. So how many things are there in here? Next minus I plus 1. Yep. Is greater than k, then we'll say int plus plus. And then we will print answer. Yes. And we're good. JK. If this is greater than or equal to it. 2, 3, 2, 3, 1, 0. Looks good. Alright, and then we'll do problem H. Mario is at a casino. The game of the casino works like this. Before each round, a player selects a number between 1 and a billion. After that, a dice with a billion faces is rolled so that a random number between 1 and a billion appears. If the player guesses the number correctly, their total money is doubled. Otherwise, their total money is halved. Well, they're going to lose money pretty quick. Marian predicted the future and knows all numbers 1 through x that the dice will show in the next 10 rounds. He will pick 3 integers, a, l, and r, and he will play r minus l plus 1 rounds. So he'll play between rounds l and r inclusive. In each of these rounds, he will pick the same number a. At the start, before round I, he has $1. Marian asks you to determine the integers a, l, and r such that he makes the most money at the end. Note that during halving multiplying there is no rounding, and there are no precision errors. Yeah, okay. So you just want to see Wait, so are you given? Oh, you can pick them. So you want the thing with the most ones of these, and you can pick any. So here you can just pick 11. 1, 2, 2. What? Oh, you pick 4. So 4 from 1 to 5. Yep. And then here you pick 1. 1 works, I guess. Here you pick 1,000. Yep. So you can always do 1. You can always get 2. So the question is like, oh, you always need the most frequent element. Yeah. So you need the most frequent element, or you need the element that has the greatest, that occurs like the most times. There's this one guy's method where you can like maintain this for powers of 2. So if you know which element you're going to pick, you have the running sums, right? So here it's like -1, -2, -3, -4, -5, -6, -5. Yeah, let's consider this case. This is the best one. Which problem? This is H. Okay, so let's say you're picking 6. So then you hit. You're gonna hit -1 here, -2, -3. Well, you start at 0, I guess, right? -3, -4, -5, and then here you get incremented by 1, right? So now you're at 4, or -4, and then here you're at -3, and then -2. No, -4, -3, -2. So if you go this to the biggest subtraction, that's 3. Yeah, and you do have an offset of 3. So you probably want that, and then yeah, you need to know what you were before and after each 6. I guess we can do that. That's fine. Yeah, 2 seconds, we're fine. Okay. So n equals this, a root array size n. We'll say these can be any value, right? Yeah. So we'll have a hash map of integer to tree set of integer. Okay, so for each integer, I guess we don't want to do it like this. Int I equals 0, less than n plus. So if a at I, so if not map.contains a at I, map.put contains key, yep, map.put a at I, new tree set. Okay, and then map.get a at I dot add I. Awesome. So now we have this tree set built. Then for map dot awesome. Okay, so we'll get the set of tree sets that we've got here, and then we need to try each one. Okay, so then this is ants equals 0. I've got print line ants. We can always do 1. Oh, we need how. Okay, so ants L. So this is not right. This should be, or this isn't right. So yeah, we need the value too. So int val will be a at indices dot first. Okay, so we're fine there. Yeah, and now I guess we need a tree set, or is this a tree map? This is like what? Let's rename this to something else. Maybe we call this like a global map. There's definitely a cleaner way of doing this problem, but this works, so I might as well just do it. So then, for each of these indices, I guess we'll say map.put. So, yes, this maps index to value. Yeah. So at position -1, what's the value? The value is 0. Okay, so then for int I in indices, int last index equals map dot highest or dot last key. Int last value will be map dot last value. Or do we even need this? We don't. We just need the min. Okay. Yeah. So int min, this, we can probably get rid of all of this. Int min L will be -1. Int min sum will be -1. Int cur sum equals 0. Int cur L equals -1. Alright, so for int I in indices, okay, so then we'll say cur sum minus equals I minus cur L, whatever this difference is. We need to subtract how many things. Then we need to update cur L, and then we need to say cur sum plus plus, because we have one more of these things. Yeah, and then we read this here. So then we can say min sum equals map dot min so if min sum is greater than cur sum, then min sum equals cur sum, and min L equals cur L. Alright, so then if cur sum minus min sum is greater than ants, then ants equals cur sum minus min sum, and then we'll say ants L equals cur L, ants L equals, min L, ants equals corral. And then we also need ants val. Val. Zero and 0. Or 1, 6. 6. This should be +1, I guess. 4, 1, 5, okay. 11, 1, 0. 11, 1, 1, million 1, 1, 6, 6 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Seems reasonable to me. Nice, nice and clean. Look at that. Look at that. Everything on the first try. Okay, 41 minutes, a bit slow. Very slow, actually, but not terrible. How are we doing? 50th place? Could be worse. Could be worse. Yeah, Rainbow is speedy. Oh my goodness. J-Thermal speedy too. Well, very good. Nice job, everybody. Anyway, yeah, those are the problems. I guess we can talk about them real quick. Sure. Yeah, let's talk about them. Okay. So problem A was, sorry for I know there's like construction going on outside. I apologize, but they're not going to stop for me. They're not big enough yet, right? Okay, we have 4 integers, so you want to see if A is bigger than B. So in this case, like if 2 is bigger than 3, or sorry, 2 is smaller than 3, that means wait, what's the question? How many people are in front of them? Yeah, so how many numbers are bigger than 2? So if 3 is bigger than 2, you add 1 to your answer. If 4 is bigger than 2, you add 1 to your answer. If 1 is bigger than 2, you add 1 to your answer. So how do you actually code this? Well, this reads an array of size 4, but you could also implement it like this. You could say int array A equals new int array of size 4, and then you could say for it, I don't know what I just did here. You could say, sorry about that. Okay. A equals new int array size 4, and then we say 4, int I equals 0, I is less than 4, fs plus, int I equals fs dot instant. So you read in each of the elements like this. And then you have your answer, which is C, and then you add 1 to it if A at 1 is greater than A at 0. Remember, these are 1-based integers, or 1-based indices, because arrays start at 0, so it's 0, 1, 2, and 3. So we add 1 if each of these things are true, and then we print C at the end. Semicolons go after this, not after this. And yeah, I think that's it. That's all we need. You can copy this, like I mentioned in the beginning of the video, you can copy this template if you want read array, but it's nice and easy. So yeah, that's the solution to problem A. For problem B, I'm going to assume you know how to read in an array of integers. So here you go. Problem B is you want the distinct elements to be as long as possible. So yeah. So for this one, you need to count how many distinct elements there are, and then you need to do a little bit of observation, but it's mostly just counting distinct elements. So to do that, I'm going to use a hash set. And when you put duplicates in a hash set, you'll only have 1 copy of them in there. So if you put like 10 2s and 3 3s in a hash set, the hash set will only have 2 things. It'll have a 2 and a 3, because it removes duplicates, because it's a set. So yeah, that's why this is very useful. You don't have to do any sorting, you don't have to do any for loops. You just you make your hash set, and you put everything in the hash set. And then the size of the hash set is how many unique things there are. Hash sets aren't ordered, but tree sets are ordered. So maybe that makes it a bit easier. So yeah, we have a hash set here. and you put the stuff in it, and then removed will be the number of things that you need to remove in order to make everything unique, because you can only have one copy of each unique element. So this is how many you need to remove. If this is even, then you're fine. You can remove one of those things every turn. But if it's odd, you have to remove all of these things, and you have to remove one more thing. Right? But everything's already unique. So when you remove one more thing, you're going to remove one more type of element. So you have to subtract 1 from your answer in that case. As an example, if you've got let's say you've got a 1, 1, 2, right? So you're going to have to remove a 1, because this is a non-unique element. But when you do that, okay, now you're left with a bunch of unique things. Anything you remove, it'll remove a type. So you're ending up with one thing. You gotta pay this penalty here. If you've got something like 1, 1, 1, 2, you can remove these two, and then you're fine. Awesome. All right, that's problem B. In problem C, this one's pretty easy. You just look for this 5 by 5 grid, right? So you've got a bishop who can attack the 4 spaces around him in the corners. And the way you can code that is you read in the board with these 3 lines, and then after you need to check these 5 things. So I'll just put them here. Let me take a look. Yeah, so this is how you read in the board, and then how you check the 5 things are you do a loop from 1 to 7, because we're going to ignore the row 0 and row 7. We don't want either of those. On both the x and the y axes. And then once you do that, you want to check that there's a space here, there's a space to your bottom right, there's a space to your, in all the other directions, and so on. So, and then you print your x, y here. To be fair, I mixed up my order of x and y, and I'm just realizing this now, but I also print them in reverse order, so it's fine. But I would recommend, if I were you, I would do yx in all of these cases, and then print yx, that way it's consistent. Because if you're debugging it, it might get a bit confusing. So yeah, that's the idea. And you can also, if you want, you can put further braces around your if statement to make it nice and clear. Alright, that's problem C. Problem D. This one is a bit complicated. So you need a couple things here. You need to check if something is a palindrome. You need to be able to add a certain number of minutes, and you need to be able to loop until you've seen a time before. So that's basically what you do, I guess in reverse order. So here's the problem. Yeah. You need to be able to do a little bit of string parsing too to get the hour and the minute. So here is the hour. So the hour is, you turn this into an integer of the character 0 and character 1. So parse substring from 0 to 2. That'll include 0, it won't include 2. So it'll be 0 and 1. And then you turn this into an integer. And then for m, you do the same thing. You parse a substring from 3 to the end, so indexes 3 and 4, indices 3 and 4, and then you turn that into an integer. And then you've got h and m. You can buy a camera from them, and then you solve the problem here. Yeah, so how do you solve this problem? Okay, so we're going to do a loop until we've hit an hour and minute combo we've seen before. So this is what that looks like. We have a Boolean array, which stores the hour and the minute. This is a 2D Boolean array, so it's, whatever. And we're going to restore both of them, so you can access both of these, and then we'll key on both of them. Only if we've seen the same pair of hour and minute before will we stop. So we're going to set it to true when we see something, and then stop as soon as we're at something we've already seen. Because then that way we know we've hit the full loop of times. Because the times are going to go in a loop. Okay? So yeah, we want to find the loop and then stop once we've completed it. And then if it's a pal, we add 1 to our answer, and then we increment by k. Let's talk about incrementing by k first, then we'll talk about checking if it's a palindrome. So to increment by k minutes will pass, but every time the minute number hits 60, the hour gets incremented and the minute goes back to 0. So it goes like 58, 59, 0, but the hour gets incremented. So as long as this happens, we're going to do that. We're going to subtract 60 from the minute and then increment the hour. And it's possible the minute will be a lot bigger than 60 when we do this. But the way this code works, it'll increment the hour maybe a bunch of times and subtract 60 a bunch of times, and it'll all even out. So this is a valid way of doing this. It's maybe a bit slow, but it works fast enough for this problem anyway. All right, so how do we check if a time is a palindrome? Well, I just build it into a string, right? So I have an hour and minute as integers, and I turn them into a string. And I do that by, I have to add 0 if the hour is less than 10, and then I have to add 0 to the minute part if the minute's less than 10, and then it's just the hour, maybe with a 0 in front, the colon, the minute, maybe with a 0 in front, and then the second. And finally, I have to check this as a palindrome. Now, this is actually a lot easier. I mean, it's pretty easy to check if a string is a palindrome in general, but this is even easier, because since we know the string is going to be 5 characters long, all we have to do is check the first and last, and second last. Because we know the middle character will match, and that's all that pairs. So yeah, it's just as easy as doing this. All right. That's problem D. How many more do we have here? Probably a bit. Okay, 4 more. Binary deck. We're going to go a little bit faster over this one. So you have an array n of 0s and 1s, and you want the sum of them to be equal to s after removing some number of things from the beginning and from the end. Now, you can count the sum initially. So initially this sum is 5, for instance, and you can say if you want the sum to be 3, you have to remove 5 minus 3 elements. So you have to remove 2 elements. But it's not obvious where these elements should be. So you're going to remove some from the beginning, some from the end. And you can just try doing all of them and count, if you do this, how many elements will be removed. So you got to be a little careful with your math, but I'll show you what the correct math might look like. Here's where I'm off. So this is actually problem E. Okay. My problem labeling got off. I got stuck with having a temp 2 somewhere. Anyway, yeah, it's whatever. You get the idea. Oh, problem E is here. Okay, never mind. I don't know what happened. So for problem E, yeah. So first we count the sum, and then I store what is the index that the sum hits some value. So it's the index that the sum hits 1, hits 2, hits 3, and so on. And then I have this array, so I can look it up very quickly. So first of all, if they want the sum to be bigger than what it is initially, that's impossible, because the sum can only get bigger, right? It's not going to get, or the sum can only get smaller. As we remove elements, the sum will get smaller because all the elements are positive. So yeah, we might have an impossible case here, in which case we can break out early. The other cases are, we need to brute force the prefix. So we're going to brute force which L, or like how many things are removed from the left side, and that's what L is. So it can be 0 or all the way up to everything. Now if it's 0, our left cross will be 0. Otherwise, our left cross will be the first index that there are L things at, plus 1. Okay, it's probably easier if I just put these indices in an array, but oh well, this is fine, I guess. Well, I guess that's kind of what I did. Yeah, it would be easier if I just like made an array of all of the... There are easier ways of implementing this, is what I'm trying to say. But this is fine, I guess. Yeah, so this is the cost of removing this many things from the left side. Kth is the number of things I need to remove from the right side. So I'm going to remove k things from the right side. And the cost of removing this is I get the index of the last thing I want to remove, and n minus that is how many things I'll have to remove from the right side to remove them. So if the thing I want to remove on the right side is n minus 1, then n minus 1 is equal to 1, and I'll have to remove just him, right? Just the last thing. And then it works if you do other stuff as well. The only other case is if I remove everything from the left side, in which case I remove 0 things from the right side. This is called a ternary operator. It's basically like an if statement. So it's like, if this is true, then use the first thing, otherwise use the second thing. That's what it's doing. And then finally the answer is, well, I could use this if I want to, otherwise I can use the best answer so far. There you go. Alright, it's problem E. Problem F, this is a really cool problem. I really like it. So for this problem, we have an array of length n, and we want to see if there are 3 integers such that their sum ends in the digit 3. So the key observation here is that we only care about the last element, right? So, or about the last digit. So although the elements they give us can go up to 1 billion, we're only concerned with like the value mod 10. So only the last digit is important. Any additional multiples of 10 we can ignore. Yeah, so that means there are really only 10 different types of numbers. There's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we don't need more than 3 of any number. So that's what I'm doing here. I store how many of this number I have, and then once I have 3 of that number, then I break out. So if I have less than 3 of this still, then I'll add a copy of this number, modulo 10, to my list of elements. And then I can just check. I'll do an n cubed on this list, because the list can only be 30 elements big. So if I do an n cubed, it'll be fast. It'll be faster than like order 1,000, and my runtime is faster than number of test cases times 1,000 plus n. So then we're fine. Yep. So then we print yes or no at the end. It's that easy. You have to be careful not to count the same element twice if you do it like this. So j has to start at I plus 1, but yeah, that's it. That easy. Okay. And 2 more problems. We've got true to the sort. Yeah, so for this problem, we've got this special condition, and we want each subarray of elements, or we want to count how many subarrays of elements are sorted by this property. So the first element times 2 to the 0 is less than or equal to the second element times 2 to the 1, less than or equal to the third element times 2 to the 2, and so on. Now, the key observation here is that the adjacent elements, we don't care about, like, let's look at these two. This one's getting multiplied by 2 to the 1. This one's getting multiplied by 2 to the 2. Instead, we could just multiply the right one by 2 and the left one by nothing, by 1. And it's the same, right? So all that matters is, like, for each pair, we want the left one to be less than 2 times the right one. And that's it. So it's very easy, right? We don't have these complex, huge powers of 2 going on. All we have to do is check that the left one is less than the right one times 2 for everything in this range. So we can just make a list of all of the places where there's like a cut point where it's not true, and we can't include this blocking point in our range. And that's what we do here. That's where I'm broken. Okay, that's what I do here. So it looks like this. We have a tree set of all of the breaks, and the reason I do a tree set here is so that I can just find the next thing in the tree set. I don't have to do any binary searches. I don't have to do any 2-pointers. It's very easy. It is a little bit slower. It's a log. It's about 20 times slower than it could be otherwise, but it doesn't matter, right? We're still going to pass the time limit. It's still faster than it needs to be, so in this case it's fine. And it cleans up the code. The part that takes the longest is us typing, right? Not the judging. So we'll let Codeforces handle this little part. So in this case, we have this tree set. That's going to be all of the breakpoints. And any time that some integer is bigger than or equal to the thing after it times 2, we're going to say this is a breakpoint. Okay, and then we just need to check for each integer, is the next breakpoint far enough away that we can have k plus 1 things in a row with no breakpoints. And that's what I do here. So I get the next thing. This will never crash because there's always going to be a thing after us. There's always going to be n plus 1 in the tree set, so this will always find something. Voice crack. This will always find something. Yeah, there you go. So then I just say, if this thing is far enough away, increment the answer. And then I just kind of calculated this in my head, but this is how far away it needs to be. Okay, and then the last problem is probably the hardest, I would say. Gambling. So in this case, what you need to do is, if you guess the number right, then you will, your money gets multiplied by 2. And if you guess a number wrong, your money gets divided by 2. Now, an easier way of thinking about this is, you can say, thinking about it in log space. You can think about what's the log base 2 of the number of money you start with, but that's really complicated, especially if you don't know math. An easier way of thinking about it is, how many times has your money been multiplied by 2? Or if that number is negative, how many times was it divided by 2? So if the answer is 3, that means your money was multiplied by 2 3 times. So 2 to the 3 is 8, right? So you just store 3 rather than 8. Or you just store 5 instead of 32. That way, your numbers stay small, right? You could store 100, and 100 is a pretty small number, rather than 2 to the 100, which is bigger than long.max value. It doesn't even fit in a big integer. So yeah, that's how you store these numbers. That's how you think about them. Or you could store negative 100 as 1 over 2 to the 100 instead of 0.000001, but the 1's going to be so far down you'll have precision errors. So you just store the number of times it was multiplied. Okay, I've beaten that with a dead horse. So then there are a bunch of ways of solving this. I think the one that I was able to just think up most quickly, although it still took me 20 minutes, but oh well, was I'm going to brute force which number you pick. So let's say I know you're going to pick the 6s. Then I want to know, when was like the prefix sum the least before us? So you can imagine we've got this prefix sum, right? Initially it starts at 0. Anytime you hit a number that isn't a 6, it subtracts by 1. And anytime you hit a 6, it adds 1. So then, if we consider the value of some range, it's going to be this number minus the thing before it. So it's going to be minus 2 minus negative 5. That's equal to 3. And that's what you get here. If you take this group, your money gets multiplied together. It gets multiplied by 2 3 times. So it's like times 2 divided by 2 times 2 times 2. So yeah, that's the idea. Now, you can't store this in an array for every number, but you can store it somewhere in like a tree set. You can do it if you know that you like only use the values that matter. So yeah, you can imagine if you have a big array of distinct values, if you tried to make an array for every type of element, you would make 100,000 arrays, each of size 100,000. So that's going to take you too much time. So instead, we're only going to look at the values that are 6s, right? That way, we're going to look at every position in the array once, and our code will be a little bit more complicated, but if all of the values are different, the runtime's still going to be fast. So yeah, here's the idea. So first, we're going to have a list of a bunch of tree sets. And each tree set will be all of the integers that have some value. So like, it'll have all of the positions that are 6. So for 8, it'll be like positions 0, 1, and 2. For 9, it'll have positions 3, 4, and 7. For 6s, it'll have 5, 6, 8, and 9. Right? So it'll have just this list of all of these things in sorted order, because it's a tree set. This could also probably be an array list. Could just be an array list. But, oh well, that's fine. And then we have a hash map of them, so it's like this is the value. So for this value, these are its list of indices. Oh my goodness, there's the traffic outside is insane. It's just literally someone's like grinding concrete. Okay, anyway. Where was I? I just can't even hear myself think anymore. We have this tree set. Yeah. So we've built this tree set now. And then we want to say we're going to consider a certain set of indices which all map to the same value. So this might be all of the 6s. And the value they map to, well, you can look at any of these indices, look in the array at that position, what element is it? So that's how you do it. You could also use the key of the hash map, but I didn't do that for whatever reason. So we're going to look at the array, and we're going to see this is like a 6. So these are 6s. And then we might store this in our answer. So ants is the number of times we can have it multiplied by 2. We can always do 1. We can always pick just one number, get it right for just one element, and then we're set. But we might be able to do better. And I'll show you how we can do that here. So we're going to store the minimum, and this is what we're going to subtract. We want the worst time it ever was whatever, and that's what we'll subtract. The worst time the sum, like the worst the sum ever was, and we'll subtract that amount. And then we want the current value of the sum. So we'll take the current value of the sum minus the worst that it was before us. So when we process another element, what we're going to do is first we'll have, there are a bunch of negative ones. We want to process all of these negative ones at once, right? So there might be a bunch of things that weren't a 6 if we're processing 6s. Our sum will decrease by 1 for each of those, so we have to do that, and then we have to update where we are. And then that might be the new best minimum. So if it is, we need to store that. Okay, and now we hit our 6. So this is the number that is the type that we're considering. So our sum will increase by 1, and then also our L will increase by 1. And then we can consider using this as the answer. So we'll take where we currently are, minus the worst that we were before this. And that's how you do it. Yeah, alright. There you go. Thank you all for watching. Hopefully that was helpful. And I will see you in 2 days on the Div4 contest. That'll be rated for me. It's on Thursday morning. That's Codeforces round 800. Should be pretty fun. Anyway, thanks for watching. Have a great day. And solve some problems. Goodbye.